A right circular cylinder, diameter 60, height 70 long. Draw the projections when it is resting at a point on HP with axis making 30° with HRP and 45° with FRP. HRP stands for horizontal reference plane, so you can call it HP also, and this is front reference plane, nothing but the VP. So HP and VP. So it is resting on a point on the HP. Object is a cylinder, so it is going to have circular top and bottom, and it is resting on one of point of its base circumference on the HP with this axis 30° inclined to HP and 45° inclined to VP. So as it is resting on one of the point of its base circumference on HP, to draw basic view we need to make it completely rest on HP. So when it is resting in HP, shape of its base, that is circle, is going to be visible in HP, that is nothing but in top view. So solution is going to start from the top view. So in top view we are going to get the circle. Once you draw that circle, split it into certain equal divisions. And name all the divisions. And this is the first division. Okay. Now project it for the front view. The height of solid is given 70 mm. So let's say this is at a distance of 70 mm above XY line. Outermost lines, highlight them and keep the remaining lines as it is. And it is going to be center line representing axis of the solid, and in case of top view we are supposed to draw horizontal center line as well. Let's provide the nomenclature. Okay, so it is going to have circular top and base, so we need to provide two names for every corner point, or every reference point has to be provided with two names. So D, E, F, G and H. Same A dash, B dash, C dash, D dash, E dash, F dash, G dash, H dash. This is going to be 1, 2, 3, 4, 5, 6, 7 and 8 dash. So this is the basic view. Now we are going to consider the axis inclination in step 2 and other inclination in step 3. Now in this example both inclinations are given in terms of axis inclinations only, but as it is resting on HP, the inclination with HP is going to be drawn in the step number 2, whereas inclination with VP, that is 45°, this is going to be considered in the step number 3. So this is 30° with HP. So it is resting on this base point, that is 5 dash on HP. So first locate that 5 dash over here and complete the remaining solid. The solid is to be constructed in a such a way that axis of the object or this side of the object, as both are going to be parallel to each other, is to be inclined at 30 degree to HP. So this angle or this angle has to be 30 degree. So draw the remaining generators as well, and finally provide the nomenclature. So A dash, B dash, C dash, D dash, E dash, F, G, H, and for the bottom and 8 dash. Okay, now project all the points for the top view. Project all the points from this basic view as well. Okay, and mark the respective points. So this is going to be 1 1 2 1 3 1 4 1 5 1 6 1 7 1 and 8 1. Okay, now similar to this one we need to project points from the top face as well. Mark those points as well. So this is A1, B1, C1, D1, E1, F, G, and H1. Now after locating the points, we are supposed to look at this front view in the direction of arrow, being standing above the object. So when you look at the object in the direction of the arrow, this ABCDE face is going to be visible face. So let's connect all those points with a visible line. Whereas this 1 2 3 4 5 6 face, some portion is going to be visible, some portion is going to be invisible. So for that reason we know that the outermost lines are going to be visible, and beyond this line the outer portion of that ellipse is going to be visible, and remaining inner portion is going to be dotted. Okay, so this is step number 4. Now in step number 5 we are going to redraw this view once again. What is the reference? The axis of the solid. Axis of the solid is 45 degree inclined to VP. So we need to redraw this top view over here once again. The condition is the axis is inclined at 45 degree. Now here what has happened, the axis length is 70 mm. That axis 70 mm remains same in the second front view also, but when it comes to this top view, this is going to represent the length of that axis. Okay, so now this is not a true length, right? So this is actually top view of axis, because it has got its length reduced, it is apparent length, and so it has become top view of that axis. Now question doesn't specify that top view of the axis is inclined at 45 degree to FRP. Instead of that, they have specified the axis itself is inclined at 45 degree to FRP, that is VP. So what we need to do, instead of drawing this axis directly on this 45 degree line, we need to mark the actual axis whose length is 70 mm. We need to draw axis whose length is 70 mm, and from that 70 mm line we will draw a locus, and on that locus then take length of this axis that you have drawn in this second top view. I am just trying to highlight that axis. So take this much length in a compass, keep compass over here and intersect this line. So this is going to be the axis now, and across this axis now construct the remaining solid. So outer portion visible, inner portion hidden, and this complete visible ellipse. So this is going to be the okay, that's fine, just refer to this view. So this is going to be the top view when its axis is inclined at 45 degree to VP. And finally project all the points from this top view, project all the points from this front view and complete the final view. Now when you draw this final view, finally you need to position yourself below this top view and look at the object in this direction. So let's say this ellipse you will be provided with a nomenclature 1 1 2 1 3 1, because this dotted portion we have drawn over here. So this portion is going to be near to the XY line, and whereas this one we have drawn away from the XY line. So this ABCD E face is going to be visible face, whereas 1 2 3 4 face is going to be a hidden face. So when you project and have intersection with the projections from the front view and locate the final intersection points, while connecting those points, this face, this is ABCDE face, so this is going to be the top face that you are supposed to draw visible. There will be those two tangent lines, and this outer portion is going to be visible and inner portion is going to be dotted one. So this is going to be the uh, final view. A cone of base diameter 50 mm. Object is a cone. Okay, its base diameter is 50 mm and axis is 60 mm. Has one of its generators on HP. Now, in case of cone, we don't have edges. So, to have some reference point, we need to split the base circle into certain equal parts and then connect every corner point with its apex, and those inclined lines are called as generators. Okay, so it is resting on one such generator in HP, one such generator in HP, and same generator is inclined at 30 degree to VP. That same generator is 30 degree inclined to VP also, with apex towards the observer. Draw its projections. So let's say this is XY line. It is resting on one of the generator on HP. So in a basic view, then okay, I have selected it. Okay. Second step is axis inclination and third step is other inclination. So in basic view, we need to make it completely rest on its base on HP. So in a top view, we are going to get the circle. Once you draw that circle, split that circle into certain equal parts. Name all those parts. Let's say this is 1, 2. Okay, this is 1, 2, 3, 4, 5, 6, 7 and 8. Project all the points for the front view. Before that, project its axis. What is the axis length? Axis length is 60. So let's say this is 60 mm. Then project remaining points. Okay, now connect the, why it is not being straight? Provide names to the divisions in the front view. So this is 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash and 8 dash, and this is going to be O dash. Here in the top view it is going to be point O. Now connect the outermost edges with visible line and remaining lines with a continuous thin line. Okay, and this at the center is going to be axis. So center line representing the horizontal and vertical center line in the top view and axis in the front view. Okay, now let's say this is the rightmost generator O dash 5 dash. That generator is to be kept in HP. So first locate this point 5 dash, take 5 dash O dash distance, mark this point O dash. So this is going to be the generator, and then complete the remaining view. Mark the intermediate points as well. So this is one, sorry. Okay, now this will try to become horizontal line. Name all the points. So this is 1 dash, 2 dash, 3 dash, 4 dash, 6 dash, 7 dash and 8 dash. Now project all the points for the top view. Project all the points from here, first top view as well. And now connect the respective points. So let's say this is 1 1, this is 2 1, 3 1, 4 1, 5 1, 6 1, 7 1 and 8 1, and this one is O1. Now if you look at this front view along the direction of arrow, this complete base is going to be visible. So this whole ellipse is to be connected with a visible line. Okay, and once you complete that ellipse, just draw a line tangential to the ellipse connecting with the point O. So this is going to be our top view. Okay. Now the generator in HP is the line at the center, this O dash 5 dash. This generator is on the HP, so O dash 5 dash is the generator at the center. Now this generator is to be inclined at 30° to VP, and while doing that apex is towards the observer. So let's draw this 30° line, and on this line we need to mark the point. Let's say this is 5 1 and this is O1, and then locate all other remaining points. Let me do it once again, this is very bad. No, it will be completely gone. This seems good. So that way you will get the base and then connect it with the apex. So this is going to be the view. So basically you need to redraw this view once again over here. I will tell you how to redraw that one. let's say this is the line at the center. Okay, so once you have located that 5 at certain distance from the 5, this is going to be that line. Okay, this line is perpendicular to axis, so this line is also going to be perpendicular to the axis. On that line, mark those intermediate intersection point. So one point over here, 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 and from those three lines draw a line perpendicular to the basic line. And from, let's say I'm going to look at point 1, 5, so from this central point take a distance of 1 and 5, keep compass over here and locate the point 5 and 1. Similarly, you can locate remaining points. Okay. Now project it for the front view. Take projections from this front view. Finally connect all the points. Okay, so we let's after projecting the points from top view and front view, we have marked the intersection points. Now if you look at this top view in the direction of arrow, being observer standing over here, the some portion of base is going to be invisible, and some portion in the sense the outer part by default it is going to be a visible portion or visible part. Then we will connect it with this apex tangentially, and the remaining internal part is going to be hidden one. Okay, so this is going to be the solution. A cube of 50 mm side has a corner in HP. So the object is a cube. Cube means its base as well as top is going to be a square. Okay, so let's say this is a cube. Now this cube is resting on one of its corner in HP. So in basic view, what will happen? In basic view, we need to make it completely rest on its base on HP. Okay, so shape of its base, that is square, is going to be visible in HP, so that is nothing but in top view. So solution is going to start from the top view where we are supposed to draw a square, but while drawing that square, the resting reference is a corner, so it is resting on its corner on HP. So when you draw that square, you need to keep corner towards the right or corner towards the left. If you keep one corner towards right, the other one is going to be there by default at the left. Okay, so let's say this is this top view of the square. Now the square has got A, B, C, D as top face and 1, 2, 3, 4 as bottom face. So let's say this is A, B, C, D, 1, 2, 3 and 4. Now project all the points for the front view. Height is also going to be 50. So let's say this is front view of that cube. This middle edge is also going to be visible. So let's say this is A dash, B dash, D dash, C dash, 1 dash, 2 dash, 4 dash and 3 dash. Okay, now what is next? Draw the projection of the cube when solid diagonal is parallel to HP. Now first let's see what is meant by solid diagonal. Solid diagonal means a line across which that whole solid gets splitted into two halves. So when you draw a line across that whole solid has a symmetry, that line is nothing but the solid diagonal. Now how to look at that solid diagonal? Take one of the corner of its bottom and connect it with another corner of the top face which is on the opposite side. So left bottom corner, right top corner, and when you connect those two lines, 2 points, the line that you get, that line is nothing but the solid diagonal. Okay, now this solid diagonal is parallel to HP. Now time being, if I try to look at that solid diagonal in this front view, we can see that solid diagonal I have connected 1 with the point C. So this is point 1, this is point C. So I will connect those two together and this is the solid diagonal. Now this red line is to be parallel to HP. This has to be parallel to HP. Additionally, it is resting on this corner on HP. So this point 3 should remain on the XY line. So this is 3 dash. And after keeping it on HP, we need to draw the remaining solid. Now how to draw that remaining solid? For that one, what we need to do in the basic view itself, from 3 draw one line which is perpendicular to the solid diagonal. Draw a line from that 3. Why I am drawing from 3? Because 3 is the reference point for the second view. So from 3 draw one line perpendicular to the solid diagonal. So from 3 I will draw that perpendicular line first. The length of those segment should be same, and from there I will draw this horizontal line which is going to be equivalent to length of this solid diagonal. So this is point C dash and this is point 1 dash, and after locating those 2 points, complete the remaining solids. So those two are going to be almost overlapping, those two are almost overlapping, and this one, as I have drawn it with as a freehand sketch. So this A dash and 2 dash 4 dash, in your case, if you draw with proper dimensions, those two are going to be exactly overlapping points. Now connect the respective intersections. So this is 1 1, 2 1, 3 1, 4 1. This is A1, B1, C1, D1. Now when you look at the object from the top, this ABCD face is going to be visible, and 1 2 3 4 face, some portion is visible, some portion is invisible. So let's connect this ABCD face first with all the visible lines. And for this 1 2 3 4, let's first connect the outermost lines, and then we will draw the remaining lines. Okay, so now remaining lines are going to be dotted lines. And now apply the rules. At corner 3, the line is going to be 3 1 C1. Two existing lines are dotted, so third line starting from that corner will be dotted one. Whereas at corner A, internal corner, existing two lines visible, so third line starting visible one. So this is step number 4. Now redraw it at a different orientation. Condition is other inclination. What is inclination? The same solid diagonal is 30-degree inclined to VP. The diagonal, where is that solid diagonal? This is 1 1 and this is C1. So this line is nothing but the solid diagonal, and here this solid diagonal is parallel to XY line. So this solid diagonal that you have got in top view, it is actually in true length. So you need not to do anything, you can simply redraw that axis in the step number 5. This is step number 4. Now we are going to draw step number 5. The reference is the solid diagonal is 30-degree inclined to VP. So let's draw a line 30-degree inclined to VP, and on that line locate the points. So this is 1 1, this is A1, this is 3 1, this is C1. On the projection of A1 itself, so let's say this is 2 1. On the projection of 3 1, this is B1, this is 4 1, and somewhere here this is D1. So this is visible line, this is visible line. This is going to be a dotted line. This is also dotted line. A connected with 4 with visible, AB visible, AD visible, and 1A also visible. Okay. Now look at the object in direction of the arrow by position yourself over here. Take projections from this view also, and complete the view. Now when you look at this object from this direction, there are two faces, ABCD and 1 2 3 4. You can clearly see that this ABCD face is near to the observer. So when you draw this final view, that ABCD face has to be drawn with visible line, and 1 2 3 4 face, some portion is going to be visible and some portion is going to be hidden. So let's project the points first. Project, take projections from this second front view as well, and now mark the intersection points. So this is 1 1, this is 2 1, this is 3 1, and this is 4 1. This 1 2 3 4, some portion is going to be visible and some portion is hidden. Some portion is, in the sense, outer portion is visible. Now let's mark the ABCD face. So this is A1, sorry, all these are points of the front view, so has to be dash on their head. A1 dash, where is B? So this is B1 dash, probably this is, yes, C1 dash, and where is D? This is the projector of D, so yes, this is D1 dash. Now this ABCD face is completely a visible face, so connected with visible line. This 1A is the outer line, this 3C is also outer line, this 1 4 and 4 3, let me redraw that, 4 3, so this 4 3 is also going to be visible line. Now remaining lines, 2 to 4 hidden line, and 1 to 2 is also going to be hidden line. Now at corner 2, two existing lines are hidden lines, so third starting from corner will be hidden. At corner D, two existing lines are visible, so third line starting from that corner is going to be visible. So this will be the final solution.